Hi, my name is Allie, and we are in the 3D 4E printing lab right now, and I'm gonna hand it off to Jordan. I'm gonna be behind the camera today.
Hey guys, I'm Jordan. I'm a senior studying biomedical engineering, and I serve on the executive board of the 3D 4E Club, which stands for 3D for Everyone. And so basically, the space that we're in right now is called Blackstone Launchpad. It's an area on campus where students can go to get information about startups, and they can get venture consulting based on ideas and stuff that they want to get done, or projects that they want to work on. But it's actually a place on campus where a lot of people tend to come and do a lot of work. It's a very collaborative environment. As you'll see around here, I don't know if you can see it back that far, but all of the walls in Blackstone are actually whiteboard walls. So people come and do a lot of studying. This is where I personally do a lot of my studying and stuff like that. But like I said, it's a really popular place for students to do work on campus, including in student organizations. And so one of those student organizations is 3D4E, which is part of the Spark SC kind of umbrella of innovative, or so we like to think, innovative student orgs. And so, yeah, basically Spark SC, a lot of Spark SC's orgs actually operate out of here. That includes 3D4E, that's us, Lava Lab, Design for America, and there's a couple other ones out there too. But if you guys want to do a quick tour of the space. So.
Yeah, well first tell us about this.
Yeah, okay, so we'll start here and then we'll make our way around. So
cool.
This is one type of 3D printer that we use in the lab. This is actually an AIO robotics. The model is called a Zeus, and what's cool about these kinds of printers is that these were actually designed by a startup that originated at USC.
Ooh,
and so,
very cool.
Yeah, and so AIO Robotics, over the last 2 years when we've been working with them, we've kind of seen them grow from this organization and this company that worked basically in the basement of one of the buildings. Like, I can see the building from here. So they were, yeah, they were our next door neighbors for the longest time, and now they're actually working out of a bigger office in Santa Monica. So it's cool to see exactly what they've been working on. Obviously, if they're moving to Santa Monica for those big offices, they're doing well. And we'll take a look at kind of the technical details on the printer and what's cool about this printer versus what's cool about a different printer a little bit later.
Cool.
Shameless plug for a printer that I put together right here.
It's beautiful.
So I put that together 2 years ago.
The Diaboromon.
Yeah, I didn't name it, but I did.
I was going to ask what the meaning behind the name was.
Yeah, so our lab manager had a lot of fun naming all of them.
Here's Mimi.
Yeah, and
Ken.
And TK, and so that's an easier way for us to keep track of them when we're referencing them instead of saying, oh, the Zeus that's on the middle of the right to the left.
Yeah, it makes sense.
So it just makes it kind of easier. It got to the point that we had enough printers that we actually needed to start calling them things, so that was our solution for it. But we'll come back to this when we talk a little bit more about the technical details of 3D printing, the different types of printers that work and stuff like that, and the things that we actually work on.
Cool.
So basically, this is a space, like I said, lots of study materials. I studied for a midterm that I had, my last midterm ever.
Oh my goodness,
yesterday.
wow,
yeah,
that is a big accomplishment.
Yeah.
That's really kind of sad too,
I know,
though.
it's sad, but no, I'm not really sad at all. I'm super excited for it. But yeah, so we'll take a look over here too. Here is another type of 3D printer. This is from 3D Systems, which is another one of our sponsors.
Cool.
All the printers that we use in this space and in 3D4E are what we call FDM printers, or fused deposition molding, which basically means that the type of material that we use is either a plastic called PLA or ABS. And so PLA and ABS just kind of differ in their melting point, and that just changes what temperature we have to have the actual metal heated to when we're printing what we want to print.
And does USC provide these printers, or how did you guys get them?
So, well, the first way that we started getting printers was we started with a singular printer, which we'll see has transformed in a little bit. And that was a Printer Bought Simple. It was a like $350 kit that kind of 6 students just threw money together in and wanted to build, get the experience, and see what, how it worked. And then after we moved into Blackstone, we actually got a couple of these guys, which were donated by some people who actually worked in Blackstone, which was super awesome. That gave us a little bit more capability to work with these kinds of 3D printers and get a little bit different experience than what we had with the printer bot.
Awesome.
And then working with AIO, they ended up giving us 3, and sometimes we had 4 or 5, depending on the needs of the club at the time. Around this time of the semester, it tends to get a little bit more hectic because people are finishing the projects that they're working on. And I'll talk a little bit about projects in a second, but
cool.
Just a variety of different places that we get them from. Yeah, this is our shelf of just random stuff, essentially. Stuff that's been printed over the course of the club's existence over the last 2 years-ish.
Am I allowed to touch this?
Yeah, definitely. And I'll talk
after
a little bit
I'm already holding it.
After you gave yourself permission.
Yeah.
So these are just examples of stuff. Some things are a little bit different than others. This is actually not PLA or ABS. It's a type of flexible filament. So we've done some specialty type stuff as well, which is pretty cool. These up here are examples of what we actually print. And then just knock everything over. So this is what actually gets loaded into the machines themselves. So everything you see down here was at one point a very similar physical structure to anything on these rolls. And it's what we call filament. And so this is either PLA or ABS. This feels like it's PLA. And so basically we'll draw from there when we're trying to print anything.
Very cool.
Moving quite along, here's Gabu, or Gabu, I don't know how to pronounce it.
Gabu.
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 Sure. And so we've actually got a project printing right now. And so you can see that basically the printer is just working. We're actually running a dual extrusion print right now. And this is for one of our teams that's working on chess fractals. And so basically what they did was they took, or they're actually still in the process of doing it, they are taking different shapes and making them into fractals using their geometry, and then basically just folding them on top of each other thousands, if not millions of times.
Oh my gosh.
So if you think of the way a snowflake is completely unique, that's essentially the same thing that they're working with, simply because at the super microscopic level, that's technically what these are printing. But the resolution isn't as good, so you're not going to get like the super unique stuff, but it still is pretty cool. We'll send out a picture of this afterwards when it completes, and you guys can see how it looks.
And so do you create a model using a program? How does it know what to print? How do you design it?
Yeah, so basically what happens is, depending on what you want to print, you can actually download what you want right off the internet if it's already made and known. And you can do that on a site like Thingiverse or other places that are kind of catalog those models. If not, you can use, there's hundreds and hundreds of different types of CAD software, and CAD is computer-aided design or computer-assisted design, whichever you prefer. And so examples of that Viterbi and USC specifically use is usually SolidWorks, Solid Edge, Autodesk, is that AutoCAD or Fusion 360, stuff like that? All that stuff, all of them. So cool. there's a bunch of them that you can use.
Got it.
There's different benefits and different cons of using different ones for different applications and stuff like that. So.
And like, how long did it take to design this?
Is
that a long process?
I think learning, so specifically with this project and with this team, I think learning how to make it and actually export it, because they had a process that involved actually taking it from one program and then going into a different one, modifying it to some extent in that program, and then loading it into CAD.
Got it.
So from there, I think they had 3 or 4 total different programs that they had to run it through.
Okay.
Once they figured that out, they said it takes about an hour to make a model.
Okay.
Once you figured it out. But it took them a little bit of time to figure out what exactly they needed to do.
Yeah, understandable.
To get it to work.
Cool.
So that's just one project that we're working on. A lot of other projects that we worked on in the past include freehand or working with prosthetics, and there's actually one right behind you if you want to grab it.
Oh.
Or I'll grab it, yeah.
Scared to touch.
And so this is an example of a prosthetic that we printed in the past. We printed about 50 of these and distributed them around the world and in Los Angeles. And it's actually not fully assembled right now. Normally, wherever there's a hole right here, you would see a string, flexible string, that when it's attached back here, you can control the tension. And when the wrist actually bends, it will cause all of the fingers to contract. So you can actually give this to a patient who's suffering from some deformity, and they can actually use it somewhat functionally. Obviously, it's not going to be as good as a super expensive prosthetic, but the reason why we got involved in this is because a lot of times kids who have an amputation or something like that, they outgrow their prosthetics really quickly. So it's not really worth buying a super expensive
yeah, that makes sense.
Device when by the time they get it, they're going to be growing out of it.
Very
and then on
cool.
top of that, it's a lot of fun for them to kind of see. We give them a coloring book, and they choose the different models that work best with their hands, and they'll color those in 2D, and then we'll do our best to actually match up the colors of their coloring of the model with what we print.
Aww.
And then at the end we give them the coloring page back with the 3D model too. So
that's
it's
super
pretty
cute.
cool.
Yeah.
So that's another project that we've worked on, that we're continuing to work on. Some of the projects we're working on this semester, we have 40 students that are actually working in 8 different teams. So about 5 people per group. And some other ones, I'll just go down a list. Basically, there's a group that's working on recreating the campus map for like a scale model of campus.
That's cool.
Which is really cool. We saw pictures of it online of San Francisco.
Okay,
and
cool.
we decided we have to try that.
Yeah, that's awesome.
For USC. So we're working on that. I know that in terms of applications and stuff like that, people are planning on doing some forms of, or at least in the past, I know that air quality research has been done based on putting it into a wind tunnel and seeing how air pockets develop based on the buildings and the environment. I know that people are trying to do virtual reality stuff with the models afterwards.
That would be very cool.
But also with the physically printed map, people are trying to have a lighted up system for all the buildings that you can push. Oh, I want to go from buildings on USC, from RTH to ANN or something like that.
Mm-hmm.
It'll actually give you a lighted path along from where you are.
Very cool.
Which would be super cool.
Yeah.
It's a little bit further down the road, but yeah, we actually have a couple of teams here right now. This team has been working on printer redesign, and I'll let them talk a little bit more about what they've done.
Cool. Yeah, I'll take the reins on this one. So basically what our team is doing, we were tasked, I guess, last semester to fix one of the sort of do-it-yourself, more simple printers that we have.
This is the one that we started with.
Yeah, and we basically redesigned it, and we're taking parts from that printer, another printer that broke down, that's sort of a do-it-yourself kind of model as well, and then also raw parts that we've actually ordered online, like these metal rails here.
What is this?
So this is actually a steel rail, and
got
basically the build plate is going to slide on these. So we're going to have to take these to. We've gone to labs all over campus asking people if they could cut them for us. We found a few. Found also a few that were unfruitful. But we got a place to cut them now. So we're gonna machine all the parts.
That's awesome.
Got a machine. If you take a look at the CAD here, if you guys were talking about, we had to design ourselves. We didn't find any of this online. These are all pieces. This is an older model of the printer, so a lot of the pieces are missing. But this is basically, you can kind of look at what we're getting at here. This plate moves back and forth.
So we actually just got a question in. Just curious, how does a student request funding for things like these?
So you can go through that if you want. Basically, I'll just say it's been really, really easy for us. eBoard makes it really easy to file for reimbursements. Basically, we spend our own personal money if we have the ability to do so, but the club can also make purchases for us, and they make it super easy. It's a very simple process. But
at the beginning of the semester, we had an initial parts list that we submitted, what we expected to need.
Cool.
But that's our 3D 4E kind of policy.
Yep.
So
that made it easy. It was really easy.
Yeah, I can add on to that. So it's going to differ depending on what you're involved in, whether that's research or something like that. If you're looking for a research grant, working in a special lab. The way that 3D 4E works is basically at the beginning of the semester we take all the project groups or project teams, and we basically say, okay, what do you guys want to work on? And so every year 3D 4E does some outreach to companies, sponsors, stuff like that, and we try and get sponsors to actually give us money. We're pretty successful with that, as we've been managing to actually fulfill all these requests for a lot of the projects that people are interested in doing. So based on our outreach efforts with companies that we reach out to and the money that we get from them to further our cause, then we are able to move that money from the organization itself into funding these projects as well. And then at the beginning of the semester, we also have like small amount of dues that help pay for logistical items like t-shirts, a lot of the stuff that goes into the 3D printing, like sometimes the filament, specialty stuff, a lot of taking care of the printers themselves because they have a lot of maintenance. If you've ever worked at a 3D printer, they work about 50% of the time. So,
great, wonderful.
Keeping them up and running is a big part of that. But yeah, basically just outside working with corporate entities and stuff like that. But,
super cool.
Yeah.
Should we?
Yeah, Brian, you want to talk a little bit more about
Sure.
This here?
So specifically what we're doing today, I guess I'll go through what kind of the project has kind of evolved from start to finish. So the sort of steps that it takes, is the design that we were just looking at. We discussed the design, we discussed what parts we had, what parts we needed, what we wanted from the printer. We decided to expand the printer. The old printer was much smaller, so stuff like that. That was kind of the first step, and then we actually designed it. That was the second step.
Very cool.
Now we have ordered parts and our printing parts. That's the third step, and now we're sort of kind of into the fourth step as well, which is actually assembling the printer.
Got it. So that's this here.
Yeah. So Ryan can talk more about this.
This looks like it was ordered.
Yeah, so these prints take a very long time. Well, these were actually the time I heard. But each one of these blocks takes about 6 hours to print.
Wow.
They're really, there's a lot of infill within them, and they're very high quality prints because...
What's infill?
Infill, if we have another piece, if inside here, none of these parts are totally filled in together, because if you did that, it would take forever. So this is probably like 15% infill.
Got it.
Whereas inside, and this is probably 30%. Every percentage you jump up, going from 15 to 30%, it's going to take double the amount of time to do it.
Dang.
So it's time or what do you say? It's we're willing to take that on because these are one of the more critical parts on this printer.
Yeah.
Because they're all load bearing, right?
They're all load bearing. They're going to be supporting the printer, and they need to be as stable as possible.
Yeah.
Foundation is key.
Also, so obviously this stuff also doesn't come out as we want it to a lot of the times. So we have to print multiple renditions of these parts all the time, constantly remeasuring, and even if the design says 1 inch, it'll come out 0.978, and then things are off. So
oh my
we have
gosh,
to continue to just
that's miserable.
That's kind of the making spirit.
So
though,
brutal.
Really. That's what we do with everything in here. Is you try, you fail, you try and you fail, and you get there, and that's how it is.
It's
3D printing. So it's a lot of fun. And so, as they're talking about, these are really nice parts. All the parts for this printer, in the end, we're gonna finish them too with epoxy. I don't know if we decided. There's a few finishing techniques you can use to make them look better, and they were actually, done with different plastic processes that the final finishing quality to make it look good. So we're gonna do that as well. But yeah, we're sort of in the prototyping. Yeah, and we're also probably going to paint the parts as well.
Oh, fun.
Just
Carnal and
so they
gold.
look.
Of course.
Right on. So yeah, that's about it.
We actually just got another question. What do you do with the parts that you can't use? Is it possible they can be recycled or reused?
Yeah, so it kind of depends specifically on what type of plastic. So what we've done in the past is specifically with ABS, it's the higher melting point, but basically what happens is you can combine that with acetone.
Oh my
You
god.
dissolve it into a slurry like this.
Yeah.
It's a little
That's
gross
insane.
looking. But
Yeah.
what it does, you can paint it onto the print bed, and it will give better adhesion.
Yeah.
So the
Oh,
prints will lift
wow.
up less, will warp less.
Yeah.
It's one of
So-
the main repurposing we've done for it.
So basically the ABS, that plastic will dissolve in the acetone, and then when you apply the acetone to the bed, as the bed is heating up, it'll actually evaporate that acetone, and it'll deposit some of the ABS back onto the bed, which will make it a tighter first layer in terms of adhering to the bed itself.
So these are like little pieces ground up.
Yeah, this one's been sitting there for a while, so this isn't a typical. This one isn't a typical representation of ABS slurry. Typically, it'll be kind of more like a not chunky, but viscous fluid. Yeah.
We're going through some great
we'll also
additives.
use these parts test finishes on.
Yeah.
So we're not
Okay.
going to use this, so we'll test it to see how can we make this look like chrome.
Cool.
So I think that's what we should do.
Hint, hint. Yeah. And then even outside of that too, there's a couple of different other processes that you can use specifically for stuff like ABS, or sorry, for PLA, the opposite side. And the beautiful thing about PLA is actually made from corn, not subsidies, but corn starch. It's like cornstarch derivatives.
Okay.
So, yeah, something I don't know. Technical jargon.
Makes it biodegradable. So if you
Oh,
left
good.
these prints out in the wild, or nature, I guess, they would degrade much quicker than any other plastic.
Yeah.
Really though.
No, there's actually I was looking at this like 2 weeks ago. There's a company that's actually making PLA cups that are FDA certified that you can use. And they're actually planting. No, they put like little tree seeds in the bottom of the cup, so that you bury the cup when you're done with it, and then it plants a tree when you use.
That's very cool.
So that goes to that question about wasting materials too. Is that it is biodegradable. So if we do end up throwing things away, it's not like normal plastic. It'll degrade so quickly, especially with the PLA, especially. So.
Cool.
And then just not to continue beating a dead horse, but the last thing that you can do is there's actually these things called filament grinders, and so basically you can take any type of filament that you have. We have like a waste bucket that we use when we just throw stuff away, and then at the end of the semester what we'll typically do is we'll either turn that into slurry or one of the other methods of kind of repurposing it. But another one is to actually basically put it into a blender, will it blend status, and then blend it all up, and then you can actually basically feed that through what I can only describe as like a sausage machine. Have you seen like Yeah, so unfortunately, bad image, but basically it pushes everything through, and then you get a new strand of filament coming out, which you can then use.
Very cool.
Yeah, not the best imagery to leave on. But so I think next we can take a look at like one of the printers in detail.
Yeah, sure. Cool. And then we're good on time, so.
Okay, cool. Sounds good.
If there's any other last questions that
definitely.
people have?
So I'll just run through this really quickly. So basically, how you would actually print something like this, and how it works, is we talked a little bit about CADing and getting your file. So once that's all accomplished, specifically with the Zeus, what you'll do is you'll take your file and you'll put it on a flash drive. But there's one right here.
Perfect.
So you put your file on a flash drive, and then you go through, you plug it in, and you select print. You can actually also, there's another setting called scan, which you can actually just put an item on the build plate and then put it in, and then it'll scan the item. And so then you can actually take the scanned item and reprint that item too. So it just depends on what you want to do.
That's awesome.
However, then you just go print, and then let's see what we have on this USB. And so you have your STL file, which is your typical universal file for 3D printing. It stands for stereolithography. History lesson. 3D printing was actually invented in, I think it was 1983, 82, 83-ish. And the company that actually became a result of it was 3D Systems. So they're still doing what they're doing. We have printers from 3D Systems in our lab, so it's pretty cool. But so then you come here and you choose which STL you want. So we could definitely take motor block here, and then do you want to center it on your build plate? Let's say yes. That's probably good practice. And so depending on how you want all of this to be oriented, basically what you can do is you can edit it and you can switch stuff that you want to do.
Cool.
So I can look at this and then I'll say I want to rotate it this much, and go from there.
Awesome.
It's starting to get a little bit louder in
this
here.
This
so
is the build plate, right? So
right.
then that's like, that bottom part is this.
Right, and so one of the cool things about the build plate for the Zeus is that you can actually remove it. Some other ones you can't. And then when you put it back in, I wish they had this for like microwaves if you want to get a look at this.
So true.
So it'll actually rotate in the tracks, and then it'll automatically level itself and slide into place.
Very cool.
Maybe, there you go. So you see that it automatically kind of levels itself.
Awesome.
And then from there, basically, you just press print. It'll go through a slicing protocol, which it'll actually cut the object into different layers. And then from there, it'll print each of those layers 2D-ish, and then it'll move the print bed down progressively as it continues throughout the print. And then at the end, you just scrape it off and hope that it's what you wanted.
So is typically the print bed stationary throughout the entire process and just this top part moves, or does that bottom part move as well?
Yeah, so it depends. There's two different types of printers for FDM, or there's actually more than that, but there's two main types. and that's either the bed moves or the extruder moves or both.
Okay.
And so with this, you can see that this height for the extruder isn't going to change.
Yeah.
It's not going to move up or down. So basically, this will move up.
Got it.
And it'll print from there. The other ones will be the complete opposite, where the bed will move underneath the extruder, and the extruder will stay at the same height, and the bed will lower, or sometimes the extruder will actually move up, just depending on how that printer is kind of optimized to work. So, yeah, if there's any other questions,
I think we're good. Tune in tomorrow for Rocket Propulsion Lab at 5:30. So yeah, I think we're good. We just gave a tour of 3D4E. So, all right.
Well, thanks for joining us, guys.
Fight on!